Hello guys, welcome to another video. So in this video, we are going to start the topic named as shear strength. So if you see this question, they have given that for a saturated cohesive soil, a triaxial test yields the angle of internal friction as 0. Which is they have given the angle of internal friction as 0. So the test conducted is unconsolidated undrained test. So in unconsolidated undrained test, angle of friction is 0. In this question, they have given that the increase in cell pressure. So in an unconsolidated under interest, the increase in cell pressure from 150 to 250 kilopascal leads to an increase in pore pressure of 80 kilopascal. So it is further observed that an increase of 50 kilopascal deviatoric stress results in 25 kilopascal of pore pressure. So the value of Skempton's pore pressure parameter B. They are asking us the value of Skempton's pore pressure parameter B. So the equation of Skempton's pore pressure parameter P is equal to increase in pore pressure divided by increase in cell pressure. So cell pressure has been increased from 150 to 250 kilopascal. 250 minus 150. Increase in pore pressure is equal to 80. So P is equal to 80 by 100, which is nothing but 0.8. So option C is the right answer. In this question, they have asked us to find out the wrong option. So if you see the option 1, they are given that loose sand exhibits contractive behavior upon shearing, which is right. Option B, dense sand when sheared under undrained condition may lead to generation of negative pore pressure. Yes, dense sand when sheared under undrained condition, it will lead to generation of negative pore pressure. Black cotton soil exhibits expansive behavior. Yes, black cotton soil exhibits swelling, which in turn exhibits expansive behavior. Liquefaction is the phenomenon where cohesionless soil near the downstream side of dams or sheet piles loses its shear strength due to high upward hydraulic gradient. See, if you see this phenomenon is not about the liquefaction. This phenomenon is called piping. Okay, so option D is the wrong one. Question. They have given the stress path equation for triaxial test upon application of deviatoric stress. That is nothing but Q is equal to 10 root 3 plus 0.5 P. And they are asking us to find out the value of cohesion and angle of internal friction. So we'll write solution. Q is nothing but sigma 1 minus sigma 3 divided by 2. And P is nothing but sigma 1 plus sigma 3 divided by 2. And the given equation is Q is equal to 10 root 3 plus 0.5 P, which is sigma 1 minus sigma 2 divided by 2 equal to 10 root 3 plus 0.5 sigma 1 plus sigma 3 by 2. So if you solve this equation, we get sigma 1 equal to 3 sigma 3 plus 40 root 3. We'll take it as equation number 1. So from the stress relationship, the equation we have is sigma 1 is equal to sigma 3 tan square 45 degree plus pi by 2 plus 2c tan 45 degree plus pi by 2. We'll name it as equation 2. So comparing equation 1 and 2, we get tan square 45 degree plus pi by 2, which is equal to 3. So by solving this, we get pi is equal to 30 degree. Then 2C tan 45 degree plus pi by 2, which is equal to 40 root 3. So from this we get C is equal to 20 kilopascal, where you have to solve the value of angle of internal friction 30 as here. Okay. So pi is equal to 30, C is equal to 20 kPa. So pi is equal to 30, C is equal to 20 kPa, right? Yes, 20 kPa. 30 degree and 20 kPa. Option B is the right answer. Here they have given that in the consolidated undrained triaxial test on a saturated soil sample, the pore water pressure is 0 when it is only at the end of consolidation stage. Because at the end of consolidation stage, all the water has been removed and the pore water pressure will be equal to 0. In this question, they have given that a dry-in triaxial compression test on a saturated clay yield the effective shear strength parameters, that is C dash and sigma dash. C dash is equal to 15 kilopascal, sigma dash is equal to 22 degrees. Consolidated undrained triaxial test on an identical sample of this clay at a cell pressure. They have given the cell pressure of 200 kilopascal, developed a pore water pressure of 150 kilopascal at failure. They are asking us to find out the deviator stress at failure. Okay, so they have given C dash is equal to 15 kilopascal. Effective angle of internal friction will be 22 degrees, and they have also given the value of sigma 3 as 200 kilopascal and pore water pressure U as 150 kilopascal. So with this we can find out the effective stress, that is 200 minus 150, which is nothing but 50 kilopascal. So the equation of effective triaxial stress will be equal to sigma 1 is equal to sigma 3 dash tan square 45 plus pi dash by 2 plus 2c dash tan 45 plus pi dash by 2. Sigma 1 dash will be equal to sigma 3 dash, which is nothing but 200 tan square 45 plus 22 by 2 plus 2c 2 into 15 tan 45 plus 22 by 2. So by solving this, we get sigma 1 dash will be equal to 154.376 kilopascal. Now the value of effective triaxial stress will be equal to sigma 3 dash plus deviatric stress. So from this we can find out the deviatric stress. Sigma 3 d will be equal to sigma 1 dash minus sigma 3 dash. Sigma d will be equal to sigma 1 dash, which is 154.376, minus sigma 3 dash is equal to 50 kilopascal, where we get sigma d deviatric stress will be equal to 104.376 kilopascal. In this question, they have given that a soil sample is subjected to hydrostatic pressure. The Mohr circle for any point in the soil sample would be. So hydrostatic pressure is nothing but hydrostatic pressure is equal in all directions. Okay, sigma, which is sigma, and this one is also sigma. So From this we can clearly say that the point of Mohr circle will be at a distance of sigma from the origin. So this is the point of Mohr circle. So in this options we can conclude that a point at a distance sigma from the origin. C is the right answer. So this question they are given as the match the following. So if you see the group 1 and group 2, regain of strength with time, which is nothing but the phenomenon of thixotropy. Regain of strength with time. Loss of strength due to cyclic loading, which is liquefaction. Loss of strength due to upward seepage, which is nothing but boiling. And loss of strength due to remolding, that is sensitivity. So R1 Q2 P3 S4, R1 Q2 P3 S4. Option C is the right answer. In this question, they have given that a consolidated undrained triaxial compression test is conducted on a normally consolidated clay at a confining pressure of 100 kilopascal. So they have given the confining pressure 100 kilopascal. The deviating stress at failure is 80 kilopascal and the pore water pressure is 50 kilopascal. They are asking us to find out the effective angle of internal friction. So we'll write down the given condition. They have given that the confining pressure, which is nothing but sigma 3, 100 kilopascal. Pore water pressure they have given us 50 kilopascal and deviating stress at failure sigma D is nothing but 80 kilopascal. Solution. With this, we can find out the value of sigma 3 dash. Sigma 3 dash will be equal to sigma 3 minus u, which is 100 minus 50. It is effective confining stress, that is 50 kilopascal. The total triaxial test sigma 1 will be equal to sigma 3 plus sigma d, which is 100 plus 80, 180 kilopascal. So sigma 1 dash will be equal to sigma 1 minus u, which is sigma 1, that is 180 minus u 50 will be equal to 130 kilopascal. So the stress relationship for effective total traction stress will be equal to sigma 1 dash will be equal to sigma 3 dash tan square 45 plus pi dash by 2 plus 2c dash tan 45 plus pi dash by 2. So they didn't given the value of c dash. So we will assume c dash as 0. Therefore, we get sigma 1 dash will be equal to sigma 3 dash tan square 45 plus pi dash by 2, which is 130 will be equal to 50 tan square 45 plus pi dash by 2. By solving this, we get pi dash will be equal to 26.5 degrees.